Welcome to the lecture Serial Peripheral Interface Protocol, that is SPI Protocol. SPI is four-terminal protocol and it is master-slave protocol. So one of the devices is used as a master device and the other devices are used as a slave device. Master will start a communication. So for this data transmission, four terminals are used. So CS terminal is used to select a device. So whenever master want to transmit a data to slave, it has to first select the slave by transmitting logic 0 on CS bar terminal. Sometimes this CS bar terminal is also written as SS bar terminal, that is slave select terminal, and CS bar is chip select terminal. The second terminal is SCLK, that is clock signal. So master transmitters clock signal to all slaves connected using SPI protocol. The next terminal is MOSI, that is master out slave input terminal. So through this, master transmit a data serially one bit at a time, and slave receives this data on its SDI pin, that is slave data in pin. The next terminal is MISO. MISO is master in slave out terminal. So master receives a data serially through this terminal, which this data is transmitted by SDO terminal of slave, that is slave data out terminal. This is master slave protocol, but there can be only one master. It is not a multi-master protocol like a I2C protocol, but it is full duplex protocol because it has two separate terminal. One terminal is used to transmit a data and other terminal is used to receive a data. So these are the four terminals used to transmit the data in SPI protocol. So SPI is synchronous full duplex master slave based protocol, and the data from the master or the slave is synchronized on the rising or falling clock edge. So user can select whether they want to transmit a data at rising edge of clock signal or on the falling edge of clock signal. Both master and slave can transmit the data at the same time, and it is 3-wire or 4-wire protocol. Sometimes the CS bar terminal is not used if only one device is interface, so that SS bar or CS bar terminal of that device can be connected to ground permanently. The maximum SPI clock frequency is 500 kHz and the maximum data transfer speed is 6600 samples per second per channel. It is 4-wire device, so it has these four signals which we have already discussed. The clock is generated by master, so data flow is controlled by master. For every clock signal, one bit of data is transmitted from master to slave and one bit of data is transmitted from slave to master. There are shift register in both master and slave. So as it is shown in the diagram, this is suppose the shift register of master and this is the shift register of slave. So at each clock cycle, this bit of master is transmitted to the slave and it is stored in this bit. This after transmitting this bit, the next bit is stored as a LSB bit, and in next clock cycle this bit is transmitted to slave. The same time this bit first bit of the slave will be stored as a first bit of this master. So data transmission is in the rotation form. So data is continuously rotating. There is no acknowledgement signal, so the communication is not reliable. So continuously data from the shift register is rotated. So through this animation, you can check how the data is transmitted. The yellow color is used to show the data which is stored in the slave device, and green color is used to show the data of master device. So at each clock cycle, the one bit is transmitted from slave to master and from master to slave. And for this transmission, this MOSI and MISO lines are used. The clock is transmitted only by master. Here it is showing at what clock which bit is transmitted. So the continuous data is transmitted even if slave doesn't want to transmit data to master. Whatever data, arbitrary data is stored in shift register of slave, that is transferred to master. Steps for the SPI communication. First, master has to send logic 0 on slave select line to select a particular slave for communication. Then after sending this, master start to generate a clock signal, and this clock signal is transmitted to slave which is selected for a transmission. The polarity of this master also polarity of clock signal also master has to select. Then master generates the information on the MOSI line and start transmitting. Master can transmit the data on MOSI line and it start receiving a data on MISO line. Now there are two types of configuration using which we can connect a number of slaves to master in SPI protocol. This is multi-slave SPI configuration, which is also called as a parallel combination. So all these devices are connected in parallel, but in this mode, this master must have a number of slave select lines. For example, here we are interfacing 3 slave devices to master. So master must have 3 different slave select terminals or chip select terminal. So one chip select terminal for one device. So here CS1 bar is connected to CS bar of slave 1, CS2 is connected to CS bar of slave 2, and chip select 3 is connected to CS bar of slave 3. So at a time, master can activate a one slave device. Suppose master want for communication with this slave 1, so it will send a logic 0 here and all other CS bar terminal will be at logic 1. So only this slave will be enabled and there can be a data transmission between master and this slave. Suppose master want to perform data transmission with slave 2, so that will be 0 and all other slave will be disabled. And then master will transmit the data to this slave. Then the MOSI line of master is connected to all devices. And MISO line is also connected to all devices, but at a time only one chip is selected. So master will transmit data to that slave and master will receive a data from that slave only. Next configuration is daisy chain configuration. Next configuration is daisy chain configuration. In daisy chain configuration, all these slaves are connected in series. So just check how connections are done here. The CS bar terminal of master is connected to CS bar terminal of all the slave devices. So master need only one CS bar terminal, and when it sends a logic 0 on this CS bar terminal, all slave devices will be enabled. And how the data is transmitted, this clock is also connected to all devices simultaneously. In previous configuration also, clock is connected to all devices. So clock is transmitted to all devices. So here also the one clock signal is connected to all devices. Now check the data transmission terminal. Master out slave in terminal of master is connected to first slave input terminal, SDI terminal, and the slave out terminal of first is connected to slave in terminal of second, and slave out terminal of second is connected to slave in terminal of third, the last, and here it is not visible, but slave out terminal of this last, that is SD0 of last slave device, is connected back to MISO. So data will be transmitted bit by bit from master to first slave. The first slave register is connected to second slave. Second slave data will be transmitted to third slave through register, and third slave data is transmitted back to master. So all these registers are work in the shift mode. So data will be shifted in right direction, and data will be transmitted through this all devices and then back to master. So this is called a daisy chain configuration. Here advantage is that only one CS bar terminal is needed. The advantage of this SPI protocol, there is no start bit and stop bit. So data can be transmitted continuously without any interruption as it is required in I2C protocol. It supports a full duplex, whereas I2C is half duplex protocol. No need for precision oscillators in slave devices because all devices work on the same clock signal. No complicated slave addressing system is used here. No addresses are given to devices as in I2C. Data transfer rate of SPI protocol is greater than I2C, that is almost twice as fast than I2C protocol. Then separate receiver and transmitter lines are there. So because of this, the full duplex communication is possible, and that's why the speed is more. It is simple for implementation. The disadvantage of this protocol is that if there is more than one slave, then wiring is complicated, and it uses a 4-wire, whereas I2C protocol uses only 2 wires. Since no acknowledgement signal is there in SPI protocol, the transmission is not reliable. Master will not come to know whether slave has received data properly or not. So error checking is also not used in this protocol as it is used in UART protocol, and it allows only single master. The I2C protocol is multi-master protocol. So different applications are there where it is used generally to interface memory like SD card, MMC, EEPROM, flash memory, sensors, temperature and pressure sensor, then ADC, DAC, digital ports and audio codec, camera lens mount, touch screen, LCD, RTC, video game controller. So these are various applications where we can use SPI protocol. Thank you for watching this video.